Hey, good afternoon, everyone, and thank you again for joining us. And it's exciting to see so many of you from different parts of the campus, including new arts initiative leaders also in tow with us. So clearly, Yessica, you being a network scientist, you are building a network already with your talk across actors and players from campus. We have English department program of liberal studies even working in, and we have computer scientists, Lucy. So it's really exciting to see a lot of folks here. So Jessica joins us as she's currently a researcher in network science and computational social sciences, where she's working with Barabási Lab. I'm not sure if folks, how many of you were on campus when Barabási was a professor here? Pat Flynn was there. That just dates Pat and I. No one else is here. He's a physicist and now he's at Northeastern, and he truly has been a revolutionary leader in network science. And so what's fascinating about Jessica's work, and including as you know, she and I got connected, she's uniquely gifted in how she's able to bring network science arts together. Right, as I was learned from her today, she still does ballet dancing. She is a contemporary dancer. She's an artist. She's an avid fitness enthusiast. So all of these things put together, and also a scientist. And a lot of her work has been award-winning projects, which has been curated and shared across media outlets and educational platforms. And then some other another gift that she has is she's an effective communicator to the public about the work we do within academia, right? How to make science accessible, relatable to audience all across. In fact, she even advises Laszlo when he should put a social media post out. That kind of happens times. She received a PhD in social complexity science from Universidad del Desarrollo, and an MSc in neuroethology from Universidad Veracruzana. Um, and she's also working as an evaluator committee at UTD, the university she got a PhD from, and the Dance Data Project. And she's going to talk to us with these amazing visuals on the screen, networks and the social complexity of art. Yes, thank you.
Thank you. Hello, everyone. Thank you very much for being here. I'm really honored to be here at the Lucy Family Institute for Data and Society. And I hope that really at the end of this conversation, you feel inspired about research using network science. Not working.
Just click the on your laptop.
On my laptop?
Just click the screen.
Okay, it's working now. Networks at and the social complexity of art. Yeah, I will present evidence on how social network connections shape the professional development of individuals and also institutional influence. And probably we can discuss as well how data, network science, and AI can help us reimagine our society through art and creativity. And first of all, let me introduce myself a little bit. I will say that, as Nitesh was saying, the signature of my work lies at the intersection of science and art. I bring computational social sciences experience with a long history involved in the art space. I have more than 20 years as a ballet and contemporary dancer, and I practice both from a theoretical and a practical experience. I've also collaborated in many science and art communication projects for the university, and I stay connected still with the art space through museum membership and through supporting the dance community in Chicago through the Generation J at the Joffrey Ballet. So today I'm going to share what I actually do in my research. And first, let's describe what a complex system is. So there are multiple definitions of that, but there is strong consensus, and it's generally understood that a complex system is made up of many interacting components leading to global patterns. And one example of a complex system is our society, that is composed of countless interconnected individuals who interact with each other and make multiple decisions every day: where to live, who to date, what coffee to drink. And over time, these individual choices shape the emergence of collective behaviors that that also lead to the emergence of formal and informal norms that are further reinforced by institutions. So understanding society through the lens of complex systems can actually help disentangle different social phenomena, from the growth of human economies to climate change and the objective exploration of less studied domains, such as the art world. And one common thought that I often hear is, well, I don't like art because I don't understand art. But what people probably don't understand is a specific manifestation of art. For example, a contemporary artwork, right? Rather than art as a system. And that is because art is actually a human universal. It is present in every known society across time and geography. And while its functions and forms may vary, art consistently plays a role in our society through communication, for group identity, and for the transmission of ideas. So this makes it possible to analyze art not only as an isolated object or as a practice, but rather as a part of the broader system that human behavior is. So for instance, we have these interesting works where they applied complexity science directly to artwork of creative careers. We have here, yeah. We have the seminal work by Brian Uzi and Jared Spiro, where they demonstrate that there is an inverted U effect on the network structure and the artist talent for the success of different shows in Broadway. We also have another study here where they used entropy and complexity measures to classify paintings, showing that different artistic styles have distinctive structural patterns. Lastly, we have this work here by Dashun Wong and his team, where they show that creative professionals in as we see here, artistic, cultural, and scientific careers, they have their hot streaks during the exploitation of the skills, which is a period of focused output that comes after a period of exploration. So you first explore different domains and skills, and then you exploit those skills. And another remarkable work of studying art as a complex system is this research conducted at the Barabási Lab that revealed the often unspoken role of institutional prestige for career success. So this paper shows that the artists that started careers in high prestige institutions were less likely to drop out and more likely to maintain visibility and high market value later in their careers over time. So this effect was observed for both the artists and the galleries. And of course, this work set the benchmark for further research using network science and complexity to study domains where performance is very difficult to quantify in an objective fashion. And building on this, we know that the power of network connections is not a modern invention. It was thanks to the work of MacLean that we know about the role of social relationships during the Renaissance, where artists relied on strategic network connections to get access to knowledge and also financial resources to become successful, leading to a rather cohesive network of individuals that allowed the creation of the famous paintings, ballets, sculptures, and operas that we continue to cherish today. And one domain where it seems to play out vividly is ballet. So ballet is a mainstream performing art that is widely appreciated around the world because of its beauty, passion, and power. And because of these characteristics, you could think that ballet is strongly bound to performance. And what we know from the scientific literature is that high performance is essential to become successful, but is not always sufficient because you need a network, a social network that extracts the value of your performance. So there are historical ties between dancers and the royalty. Actually, ballet emerged as an aristocratic practice. So that suggests that social positioning has long played a role in shaping dancers' careers. So this pattern points out to a highly centralized system consisting of the network of relationships and hierarchies that ultimately select the dancers who are promoted to the higher ranks beyond their physical abilities alone. So in this research, our primary question is, what is the role of modern network connections and prestige for the career success of ballet dancers? And to answer to that question, we collected the data from the Youth America Grand Prix, which is one of the largest international competitions today. We collected data from over 6,000 ballet dancers competing at the YGP from 2000 to 2021. And from the data, we traced the career trajectory of the students, and we looked for the number of participations they had, their awarded medals, and their academic affiliation. And you can see here a sample of the structured data where we have the competition outcomes, including being a finalist, the student's affiliation, of course, and the success variable that will indicate whether the student obtained a job placement in a ballet company or not. So from the YGP data, we built a network of ballet academies based on the students' participation in the competition. And in this network, 2 schools are connected if they were able to produce a top student under the same competition setting, therefore reflecting a degree of similarity in training quality. And so we propose that the systematic positioning of schools as top contenders will establish a hierarchical prestige based on a school's connectivity, where their high achievement contributes to their social prestige because it is directly perceived by others. So we filtered the network backbone, as you can see here in yellow, and we found these high density community-based connections that you see in yellow. And then we applied another stronger filter to focus only on this small fraction of highly central schools that are supposed to be in strategic network positions with very strong ties. And you can see that these academies in red, as you see here, have high between centrality, and they are connecting this kind of yellow bubbles. So they are acting as bridges. So we ranked all the academies by this between centrality and validated this ranking by comparing with public rankings of top schools as identified by third-party ballet experts. And what we found is that between centrality is a better indicator of social prestige when compared to other centrality metrics, like only degree centrality or eigenvector centrality, which is a more commonly used metric of social prestige and influence. And these results suggest that in the ballet academic ecosystem, social prestige is mostly related to showing high performance between communities. Then we use this validated measure as a proxy of social prestige and quantify the effect on job placement using a logistic regression model. And in this model, the dependent variable is success, of course, measured as a binary outcome, where success equals to 1 if the student was able to obtain a job placement in a ballet company and 0 otherwise. And what we find is that the effect in the chances of getting a job placement for the student affiliated to the most prestigious institution increases by 200%. And this increase is only comparable to highly proficient students who were able to advance to the competition finals. However, these models are still unable to disentangle potential interactions between performance and prestige, right? So what we did was to compute a matching experiment in which we match students who have identical competition outcomes, but who differ on a school's prestige. And what we find is that by comparing equally skilled dancers, we reduced this effect of social prestige from 200 to 65%, therefore removing the biases due to observable confounders. And beyond the potential reverse causality relationship here, like what was first, the prestige of the institution or the prestige of the student, or potential selection biases of the same institutions recruiting only high proficient students, our results strongly suggest that early career outcomes are overwhelmingly shaped not only by talent, but also by structural advantages. So take, for example, the principal dancers of the American Ballet Theater, whose names are in our data, most of them, at least 12 of them have participated in the YAGP. And for those that did not advance directly from the affiliated school of the ABT, the American Ballet Theater, all of them come from top schools as identified in our ranking of prestigious academies, including Isaac Hernandez and Christine Shevchenko, who are students from the Rock School for Dance Education in Pennsylvania, which happens to be the top one school in our network. So the complexity level of career dynamics in ballet is of course not reduced to the school setting. In professional ballet, networks continue to shape the access to opportunity, and moreover, gender seems to play a role. Now, please raise your hand if you think that ballet is strongly associated with women. Okay, fair. Yeah, you're right. I mean, it is strongly associated, and actually women are considered the economic drivers of the industry. Despite their majority in the field, women remained underrepresented in leadership positions. Therefore, in this project, we investigate whether women's local network actually plays a role in their underestimation of creative leaders. But now, let me just drink some water because I'm going dry. Thank you. So the problem of representation of women in ballet seems to be accentuated by career progression, where you see that they start with a 9% majority for a school level to a 25% in leading positions. And this is a very interesting phenomena because men and women in ballet receive gendered training technique. Okay, you see that women use point shoes and tutus versus men that specialize in higher jumps, for example, or holding the women when they're dancing as a couple. And also, we have gendered roles in the shows that we see. For example, if you go see the Swan Lake, you will see a lot of women, and this is a gendered role. The princesses are also gendered roles, etc. But they can be perfect substitutes when it comes to leadership roles, right? Like you don't have to have a gender to create a choreographic work. So in recent years, the English National Ballet pioneered the promotion of female-only choreographies through the She Said and She Persisted programs, and later the American Ballet Theater and the Boston Ballet joined this initiative through their women's movement and the Choreograph Her programs. But despite these efforts, the Dance Data Project still reports a 27% of female participation as leading creators, at least in the United States. So to understand these structural mechanisms and imbalances, we analyze historical ballet collaborations of 4 renowned ballet companies, the American Ballet Theater, the New York City Ballet, the National Ballet of Canada, and the Royal Ballet of the Royal Opera House. And we build a collaboration network from the collected data. That there is a sample here from which the data includes the ballet titles, the artist name, and all the credits of the artist. And we transformed it to a bipacted network, as you see here, from which we projected the network that will function as the collaboration network of ballet artists. And we only include leading creators, that is any choreographer, composer, librettist, or designer of any kind. And we assume an equal distribution of labor in the teams. The gender of the artist was inferred from the name of the artist using validated databases. And what we found is that women are actually located at the periphery of the network, as you see here in purple, that seems to be more like black, respect to the mostly central men that you see here in yellow. And this is very interesting because we find only one woman for every 4 men, which is even less than previous reports of women in leadership roles. And there is a subsequent gender gap in degree in centrality. I am showing here degree centrality, but this pattern is constant across other centralities that we tested, where the most central man is about 4 times more central respect to the most central woman. So to understand the implications of these structural imbalances, we measured the perception errors. The perception errors are nothing more than the difference between what is in your local network respect to what is in the entire network. And these are, of course, mathematically derived perception errors, but still we can have a notion of how will people misperceive specific attributes in their network. For instance, if in the local network there are more women, as in the example here, but in the local network, in the entire network, there are more men, you will have an overestimation of the women's group for the context of this research, which can strengthen the formation of groups because you find affinity between similar others, or you can reinforce personal views. On the contrary, if the perception error is below 1, a person can underestimate the frequency of their own personal attributes or views and develop a sense of false uniqueness. So we compare the perception errors with those from 2 randomized models. We randomize first the collaborations, that is who is connected to whom, holding the number of individual connections. And we randomize the gender as an attribute of the artist over the same empirical network. And our results show that all groups tend to misperceive the size of the females group. And we also see that by randomizing the network, we break gender assortativity, resulting in a reduced gender gap that is a closer relationship of the perception error and a more accurate perception of women with a value closer to 1. So this suggests that gender disparities may actually be derived by other than random factors, such as systemic social mechanisms, gender preferences, and other social selection preferences that happen at a local level. But what are the implications of this for women? So in the workplace, they can feel less represented. They can affect their career decisions because they may not have enough role models. And also they can potentially decrease their confidence to undertake leading positions in the field, something that will lead to what is known as the glass ceiling effect that we already observed in this specific area. So overall with this research, these 2 projects related to ballet, we see that ballet is actually a networked complex system. And I showed you evidence on how social stratification shapes the access to professional opportunities, similarly to what has been observed in other careers where performance is very difficult to quantify, such as the academia, music, or the visual arts. Likewise, this work shows that the influence of collaboration networks have the power to impact career decisions for professionals beyond their talent, as well as the emergence of organizational leadership. And you can have here the QR code for the published work if you want to read more about this research. But for now, let's navigate deeper into the art world toward the powerful force of philanthropy. So in this project, what we do is to reveal the hidden institutional connections of philanthropies who often act as influential gatekeepers of artist visibility. So the art world is a network of actors that compete for power and influence within a complex set of social relationships. So Bourdieu conceptualized the field of cultural production and considered 4 different axes: economic capital, cultural capital, social capital, and symbolic capital. So the key idea here is that actors in the art world are positioned based on how much cultural and economic capital they hold. And we will focus on the field of power here. That is a very specialized part of this network for those with high economic and cultural capital, but that have successfully used their social capital and have obtained symbolic capital through their endorsement as authorities from others. So those who are in this field of power achieve control over what is considered valuable in the art world, and they get dominance sometimes over what gets produced, exhibited, and even remembered in the world. So in this setting, we have different actors that navigate this social structure strategically to attain prestige. But ultimately, what they are looking for is influence and power. And our main question is who actually influences what we see in the art museums? And to answer to that question, we collected over 2 million artwork records from 15 leading art museums in the United States. And this data actually give us the opportunity to see beyond museum collections and to quantify strategic connectivity, that is strategic connectivity that shapes artistic visibility across the most powerful America's art collections. So in this research, we focus on art collectors whose philanthropic influence is well known to shape the art world. And we extract the names from the credit line of these artwork records. And the first step is that once we collected the semi-structured data, we validate all entities using Spaces Name Entity Recognition models. And to handle with the high heterogeneity that we had, we created an AI-guided pipeline for cleaning and matching with the goal of linking name variations of the same entity as you see in the example here. You can see how varied the strings are, and this will be our goal. Okay, so what we did is to create the pipeline. This starts with doing a manually curated training dictionary, grouping name variants of the same identity. And this dictionary was used as an input for OpenAI's ChatGPT-4 to map patterns of name variations, which are handled through a multi-layer process using regex rules for normalization and cleaning. So then we implement a matching on alphabetical batches for root names, using root names as tokens, using the Levenstein's distance algorithm of string similarity. And there is an example here. I'm not sure if you all can see it, but you will see how this algorithm works through this diagram. And so all the names matching multiple strings are exported into JSON files for a final manual validation. That will be this step. And those incorrect matches were removed from the data. And as a result, we obtain a structured entity names in the dataset. This is a sample of the prompt that I used. And just mind that a single prompt, because we had a lot of heterogeneity, not only within museums, but also between museums. So a single prompt was not enough because the data showed, high complexity, as I showed you in the example, and multiple layers were needed to gradually resolve different variations and preserving accuracy, rather than just oversimplifying diverse cases of different entities. However, the automated parts of this pipeline are deterministic and rule-based, with the code executed at a local level. So we don't have, so our methods are reproducible and are independent of AI model inference. So our data resulted in over 100,000 artists and around 60,000 collectors. And we further use the Spaces Name Entity Recognition again, but now to classify the entities as either a person or an organization. And we confirm the entity of artist using a previously collected Wikidata list of artists. But now that we can move on, now that the data is ready, let's move on to the actual implications of the work that we want to study. So first, we try to capture cross-institutional influence, and we categorize the collectors as local for those that donated to one single museum, and also global for those that donated to more than one museum. And we find that about 12% of collectors donate to multiple institutions. And interestingly, this collector seems to be increasingly more active in the last decades, raising the question of whether museum leadership is probably adapting their strategies to attract donors beyond their local constituency. But we have an example here of the Whitney Museum of American Art. This has almost, it's at the bottom, I'm sorry about it. This has almost an equal representation of both local and global collectors, probably derived by their actually very open efforts offering engagement opportunities within the United States and abroad. It's a very flexible museum in that regard, but also because of the evolution of what is meant by American art, as we were discussing previously. They are actually opening the definition of what American art is or what American art represents by, for example, including artists from Caribbean diaspora, because there is a high representation of Caribbean communities here in the United States. So that will be a flexibilization of what American art means. And while this will deserve further research, this initiative could motivate collectors at the same time to engage in broader giving. So we ask, how are collectors spreading their donations? And what we see is that global collectors mostly centralize about 70% of their total donations, correlating with previous studies emphasizing the locality in art philanthropy. And there is, of course, a decreased percentage of their donations given to a different number of museums. But we further look at how deeply collectors share artist works and define casual collectors as those that only give one artist once, and engaged collectors as those that donate the same artist repeatedly. And what we find is that about 40% of the total collectors show engagement to the artists that they cherish. And we examined the breakdown of these groups that we formed. And we found that overall, 9% of the collectors donate multiple artworks, this is this part, per artist to multiple museums, emphasizing the importance of collectors' engagement to both museums and artists. Yet these descriptions are very interesting, but are still unable to identify the actual mechanisms of influence or how collectors become influential figures in the art world, right? So to understand the actual mechanisms of influence of these collectors, we use network science. And this is a representation of the network that we use, in which artists are connected to collectors if the collector appears in the artwork record, in the credit line of the artwork record, and collectors are connected to the museums if they donate that artwork to that specific institution. Therefore, collectors act as bridges or gatekeepers, promoting artist visibility in public institutions. So to quantify collectors' influence in the network, we introduce collector flow centrality. This measure captures how widely and intensely a collector can increase artist visibility across museums. And this equation first sums all the number of artworks from an artist that are given by one collector to all the museums. And the value is then scaled by a log factor, a log-based factor that increases with the number of distinct museums receiving the artworks. So in this case, we are using the log factor because we want the transformation to be equal to 0 if all the artworks were given to only one museum. That is the logarithm of 1 is 0. Then that gets rid of those artworks that were given to only one institution. And then the result is then summed again here for all the artists that were donated by the collector to produce the collector centrality score. But we focus, after doing this, we focus on those collectors that have collector flow centrality greater than 0. And we name them gatekeepers, because these global and engaged collectors are strategically positioned to to enhance artist visibility by placing their works across multiple institutions. And this is the network of the gatekeepers that we have. And in this network is very interesting because the edges have the color of the main institution of the collector, so we can see interesting relationships. I think that the labels are very little. I'm not sure that you can actually read the names, but we have here the Rosenbach brothers, who were very influential figures at the Philadelphia Museum of Art in green. We have Reba and Dave Williams here and their strong connections with the National Gallery of Art. And we have Leonard Lauder, who you may know from the Lauder company, the Estee Lauder, the cosmetic brand. So he is here highly connected to the MFA in Boston. But then we ask, who are these gatekeepers? And surprisingly, we find that only about 4% of the total collectors qualify as gatekeepers. And interestingly, at least in the top 100, we find an equal representation or a similar representation of artists and collectors. Also, we find that every museum in our data has at least one donation from these gatekeepers. And altogether, this highlights the often overlooked role of artists as gatekeepers and philanthropists. And second, the network connectivity is very prominent and very dense across different institutions. But what we wanted to explore next is what makes the difference. How do you become a gatekeeper in the world? And so let's compare these to the Lauder brothers. So you have these two individuals who are from the same family. They have a similar career age and similar age and career in philanthropy as art philanthropists, yet only Leonard Lauder, who sadly passed away last June, only he became a gatekeeper. And what you can perceive from this diagram is that gatekeepers start giving to a second institution probably earlier in their careers. They tend to give more artworks and they engage with a larger number of institutions. So we used a fixed effect models using cumulative metrics that I will explain later to model the growth trajectory of collectors. And we control for time, in which time will represent each donation event. It's not about the year, but it's each donation that a collector did to a museum. And we have the post-event indicator that tells us when the collector became global. So we have the before and after, that will be the time zero. We have the groups of interest being a regular global collector versus a gatekeeper, and we fixed effects on collectors to account for all the individual career heterogeneity. And these are the metrics that we used. Very simple metrics, except the one in the middle that is a little bit more complicated, but very easy to understand. Cumulative donations is just the total number of donations over time. We have this metric that is Museum Attention Index. That is no other than Simpson's Diversity Index, if you are familiar with that. If you have a business background, that will be the Herfindahl-Hirschman Index, that is the complement of Simpson's Diversity, but it is not other than a metric that captures, for this context, how evenly the collections are spread across different institutions for each time point. So if all donations go to one institution, there is no diversity, and that is why you have a flat line in the before zero, before the time change event. We also have the exploration of new artists, which is just the count of the number of new artists added to the collection of the collector. So we find evident distinct trends that you can see from the diagram, where the purple line is clearly separated from the yellow line, right? And the models were statistically significant for the relevant parts, showing that gatekeepers start with a lower activity in general, as you can see here. It seems to be a lower activity in general, yet after giving to a second museum, they improve at a faster rate than global collectors from that point onward. So while this is still a work in progress, but for now, what we can learn from this work is that first, our centrality metric can actually show us that influence is more about distribution and reach rather than just collection size or local presence alone. And also, we see that the gatekeepers emerge or seem to emerge from their actual giving behaviors. They have higher acquisition power, of course, but more importantly, they have richer cross-institutional participation and broader artistic exploration, which for those that are interested in the art space will learn that collectors are highly valuable within the community because they're unique taste. So they need to prove that they have enough money to buy expensive Andy Warhols, but they also need to show their own identity through the exploration of new trends and new artists. And lastly, because it's already late, let's pass really quick to discuss about what is the future of data and art and society. So I asked ChatGPT about what he thinks about it. And this is what he says. And I agree with the M dashes and all. But I think that honestly there is much more, right? There is much more potential for that collaboration. For example, to generate or to use this cultural data for predictive modeling, like to understanding the changing art markets that we are already seeing with the steep generational changes. I was listening to a conversation where at the Art Basel in Miami, no one was revealing the price of an Andy Warhol artwork because the price dropped significantly because the new generation, the younger generation, they don't care about Andy Warhol. They want to collect the sneakers. So they were like, what is going on here? So trying to see and trying to predict what's going to be valuable or what organizations should do to keep the value of the old masters and of the iconic works that we have in the art space, it's going to be very interesting to learn from these kind of rich data sets that we can create. Also developing machine learning models for the curation of or authentication of works is another application. Likewise, we have the development of new technologies for creative industries that are very user-friendly, like for example, Adobe. I'm not sure if you have explored Adobe Firefly, for example, or Canvas, or all the applications for Instagram and social media, and trying to expand the ongoing debate on the ethical use of generative AI in the art space. Is it a valid art form or not? Is it going to replace artists and designers or not? What's going to happen, right? This is an ongoing discussion. We also have a growing field for research on human AI interaction. For example, there is a strong use and strong attention on using dance theory and artistic performance in robotics, as well as the application of AI tools to understand what happens in the brain, to understand the underlying mechanisms of visual perception and aesthetic experiences. Also, I think that there is a growing interest in creating new methods, here in the last number, for visualizing and interpreting social systems that make information easier to communicate across audiences, which will also have the power to reimagine our society. So for instance, at the Data Art Symposium at Harvard University, we saw researchers from various fields incorporating art and design to find creative ways to study different phenomena, conducting data-based research from social systems to study patterns, for example, in biodiversity. So there are multiple applications. Also, we have the Data Land Museum, which I'm not sure if you've heard, but it's a museum that is expected to open this year in Los Angeles. And this is a very good example of where art and generative AI are going. Interestingly, this museum or this project was originally premiered at the World Economic Forum in 2024. And earlier this year, the McKinsey & Company did a showcase, a coverage of this specific project. And this shows you how data and art and initiatives at this intersection are already receiving attention from structures of economic growth and technological development. And also, while I was developing this work, I had the opportunity to talk to people at the Indianapolis Museum of Art at Newfields I'm not sure if you've been there, but it's a very beautiful museum. Should go. And they express the interest in this data-driven approach to understand the complexity of the art space, where they also see the need for museums and cultural organizations to have their data ready and available and accessible, not only for research purposes, but also for creative outputs. Lastly, I think that there is a growing interest of philanthropists supporting art and tech initiatives, like, for example, the Knight Foundation and the Templeton Foundation, to some extent, are institutions that have an explicit interest in these kind of initiatives. So I think that across disciplines, industries, and institutions, data and art are no longer separate worlds. They are becoming one of the most powerful combinations to increase our understanding the complexity of our society. And before we move into questions, I just want to take a moment to thank the amazing team of researchers, mentors, and collaborators who made these works possible. I am really deeply grateful for their ideas, their time, and of course, their trust. And that is all I have for you. Thank you very much for your attention.